So without further ado, Mike, let me give you a microphone and it's all yours.
Yep, my name's Mike, and you heard N6MO. Been around the Bay Area a long, long time since I was the age of 1, so I know this area real well. But I'm based over in Cupertino. Used to work in Palo Alto at the Ford Aerospace Loral, and then eventually became Lockheed Martin. Even closer? Okay. Okay. Thank you. Let's see if it moves. I'm pushing. Oh, there.
Hey.
Okay. Sort of my background on stealth HF antennas. It probably helps in the audience to understand. Does anybody live in an HOA in the audience? Raise your hand if anybody's in an HOA. Okay.
Not on a bet.
Okay. How about an apartment? Anybody in an apartment? Okay.
No.
Okay. And how about a townhome or a condo kind of arrangement? Anybody in that? Okay. So it really does apply to a lot of us as we deal with housing. But stealth means different things depending on how you approach it. And the way I'm going to approach it is if you have to deal with an indoor antenna, I've done that many times at hotels, motels, and condos that I'm renting for a vacation. Uh, a lot of people in apartments and condos have to deal with the indoor antenna arrangement. So I'll cover some on that. Ideally, it can't be a Faraday cage. Has anybody ever tried to go into a hotel that is concrete reinforced with steel and has stucco on the outside? I've tried doing that and I can't hear anything and I can't really get anything out because it's a nice shielding environment all surrounding the complex. So your only outlet is if you can open the window and send the antenna out the window. So I've, in desperation, I've done that too. You'll need a typical room size. However, Meg Loops will allow you to get around some very limited room sizes. If you've ever gone to England, sometimes rooms are tiny, and in Japan, they're very tiny, so you can still operate that way. Ideally, if you have a window or balcony, a window that opens and a balcony that you can gain access to, that's really pretty nice. You can do a lot with that. The attic antenna, you will need attic access. A number of condos, they don't want you in the attic, so that can be a problem. Sometimes they only want maintenance accomplished in the attic and owners to stay out. But ideally, you can't have radiant barrier insulation. Does anybody know what that radiant barrier insulation looks like?
Got foil on the back of it.
Yep, it's got foil. Makes a nice shield on the whole roof assembly. So, however, you can take advantage of radiant barrier if you want to do a vertical that can poke out the top of the roof. You can use the radiant barrier as your counterpoise, but that's a little work. And that little vertical that's sticking up out of the top might be non-stealth in terms of some homeowners. But I have used extensively attic antennas, and the beauty of attic antennas, they can withstand all the weather and never have a problem. Where your antennas on the outside, you may have difficulties through storms, hurricanes, tornadoes, whatever may exist. Those aren't much of a problem in the Bay Area, though. And then the stealth exterior antennas, I'm going to cover some on that. You really want them nearly invisible so that your antennas or the HOA Nazis aren't going to come by and say, that's an antenna I see there, and I'm going to have to fine you for that. So if you can make them invisible from the street, invisible to your neighbor, you're in good shape. And we'll discuss some of those options too. Okay.
Okay.
Some of my sort of long stealth antenna history is I started this when I was a novice in 1968. That really dates me, I can understand, because I've been doing this for 57 years. But at the age of 12, my parents got a townhome over in Lake Tahoe, in Tahoe Keys. And the most exciting thing I thought is it's got an attic and I can put an antenna in it. So I crawled through the attic and put my 40-meter dipole up there and thought I was in paradise because I was still operating, making CW contacts. No matter, they were in the same state or neighboring states or within the U.S., I was happy to make a contact. And I didn't care about performance. DX to me was getting out of California back then. And I was making contacts. So that's what started me into some of this stealth stuff. I have operated from 14 homes, both the primary homes and vacation homes. People ask me how many do I have? Well, I have 37 homes, but I operate half of them in HOAs, and the other half are in non-HOAs. And what gives me a real luxury is I've got an 80-foot tower in my non-HOA and a 40-foot tower in Cupertino. It was originally county, so I got away with that, and now Cupertino wouldn't permit it, but I put it in over 30 years ago. So I use that sort of as my baseline sometimes as I try out antennas and then move them into the HOA areas. I can at least get an idea, well, what's this do compared to my high-end antenna up at 74 feet, which is an OptiBeam. This is not going to go deep into theory. This is not a PhD dissertation, but it's more my experimental data and results. And a lot of it is also tied to modeling, but I will be honest, there's so many models out there, all you have to do is look them up. You don't have to generally run them. So I've taken advantage of everybody from LB Sevick and his models to others who have done some wonderful modeling. I have tried out about 95% of these antennas, so I can sort of testify how they work and the ones that don't work that well too. I have tried to minimize, when we're dealing with stealth, you want to minimize losses. And you see so many antennas and you need to look a little more closely, like a Wolf River coil. It's a stainless steel coil. It's a semi-lossy coil. I have a great respect for, you probably met him, Tom Schiller, N6BT, Mr. Force 12. He actually flew a drone to find out how lossy some of these coils are. And it was a little bit concerning. We're talking about, 3 to 8 dB worth of loss. So as I'm trying to get my stealth antenna to radiate every bit of energy I can put in it, the last thing I want to do is warming up coils and taking my signal down. So I tend to use more linear loading and instead of coil type loading. If you have to use a coil, make it extremely low loss, and at least you won't suffer too much. But stainless steel is about a minor amount of conductivity compared to aluminum and copper. So you want to take advantage of getting as much conductivity as possible. I'm also fond of getting the high current portion of the antenna as high as I possibly can. That's going to really be the effective part of your antenna, the most important part. So figure out where the high current is, get it up high in the attic, high in the tree, wherever it may be, and you're going to get a lot more effectiveness. I've also played around with, if you're stuck on the ground floor, some condos are only one floor, patio home, you got to maximize out of being on the ground as opposed to being on the third or fourth or fifth story kind of thing. So you're typically going more towards the vertical polarization to get as much low angle energy out there instead of getting all NVIS straight up in the air, 90-degree kind of angle. So you have to evaluate, how high you can get it, what your alternatives are. Even look at your large metal surroundings. I've taken advantage of metal aluminum patio covers. They are great counterpoises. If you put a stealth vertical in the middle of it, you're gonna pick up about 3 or 4 dB out of that arrangement because it's both elevated and a wonderful counterpoise. And if you can, get verticals elevated, that works to your aid. I'm not fond of having verticals on the ground. They tend to warm the ground for you, but you're losing a lot of energy that way. And then if you really want to get nerdy on this, you can evaluate your topography. I remember Dean Straw, did a whole lot of modeling of topography to figure out, okay, if you put it here, what's your radiation going to be like? And the easy one is if it's sloping down, you're going to reduce the angle of your radiation and you're going to have more favorable DX contact arrangements. And I even noticed that between moving an attic antenna that had sloping ground towards Europe and an attic antenna a mile away that did not have sloping ground towards Europe. And I was picking up about an S unit out of that sloping ground arrangement. And if you're even blessed more to have salt water right out the backyard, I cannot believe that. I don't know if you've talked to G4 AKC on his bicycle. He rides his bicycle from a mile from town right to the salt water. He picks up 10 dB right there next to the salt water. And so I've talked to some people like in Florida whose vertical antenna is sitting on the boat dock, and they're picking up 10 dB. So what happens, a normal vertical becomes the performance of, say, a hex beam or a good sized beam, just because it's got that salt water. Does anyone know why it does all that? The ground conductivity. Yes, and you're talking about angles that now go from, say, 15 degrees down to 1 or 2 degrees. And again, Mr. Force 12 N6BT set up the vertical arrangement that won the contest and set world records because their verticals were right next to the beach and a whole array of them for every single band. And they just cleaned up having verticals in that arrangement. So if you happen to be fortunate right next to salt kind of water, and even I found if you're in fresh water, it's still a better ground plane. And I typically pick up about an S unit if I'm right adjacent to fresh water as well. Not as nice as the salt water, but you still gain something. But and you should look at your, I call them organic masts and towers. Your organic masts and towers are your friend. I've had some redwood trees 70 to 100 feet adjacent to my property, and why not take advantage of them? Now, I don't recommend shooting bows and arrows and all that kind of stuff. You may have the police visiting you, but you can, shoot the pneumatic kind of air guns, and get something over the tree, pull up a nice antenna over the tree. Okay, yeah, sure, go ahead. I'll repeat it. That's a good question. I don't know if I can even answer how it actually lowers that angle through being adjacent to salt water. Does anybody have any detailed theory behind it?
So I'm not an expert on the physics behind it, but I have a general idea. Basically, whenever you're using a vertical antenna over ground, the ground itself will act as a capacitive element as part of the antenna. And when that ground is lossy, it's going to behave kind of like a Yagi reflector. So it's going to send the radiation pattern more upwards. Whereas if it is highly conductive, then the self-capacitance of that ground is going to effectively slosh the RF energy back on the backswing, so to speak, and return it to the antenna on the next cycle.
Okay. Yeah.
They probably could anyway, but from what I understand, it only works with verticals. It doesn't work with dipoles that are horizontal.
That's correct. That's correct. And that's what Tom Schiller did a lot of experimentation with to find the net effect of verticals and prosper in contesting and doing de-expeditions as well. Okay, here's a question to throw out to the audience. I was working a big signal. It was a stealth station, W7CUI. He's in Washington. His signal was 5.9 plus 10 to 20. He's operating 100 watts, and he's living in a luxury retirement condo. He's a retired medical doctor. He's not really, electronics specialist. What was his antenna? And do you know the secret sauce to his situation? What's that? Ah, that's the real key, the clue. He's on the 21st floor. He's on the 21st floor in his luxury condo. And here's the details. All he has is a Yaesu ATAS 120, which is a dinky vertical that you put on your car. It's about 6 feet. It's about 3 dB worth of loss compared to a reference dipole. And he's putting out a monster signal because height is might in this situation. And so he had a very low angle radiation, very little ground loss. And of course, he has a metal balcony that's tied to all the metal in the condo arrangement. So he's got a great counterpoise as well through all the metal on the building. So I thought it was a very creative alternative. He's operating 10 through 40 meters, putting out a big signal, and this guy has his dinky antenna. Now, admittedly, the condo costs more than $1 million, but yeah. Mhm. Yeah. Nice. Yeah.
Let's get the, we're not hearing
So-
the questions or comments.
Yeah, his comment was really in a lot of housing, rental housing, they're giving a lot more latitude because of the federal laws about TV antennas, and a lot of people are exercising them with ham antennas on balconies, and I'm seeing it in all sorts of HOAs, and I'm actually HOA president of 3 HOAs, and I don't even wrestle with people on that issue. I just let it be. So
Got one
Thank
for you.
you.
Basically, if you're on the 20th floor, you could simply use a fishing weight, a fishing pole, and just hang it out over the edge, drop it down with a 22 gauge wire. You can take 100 watts on a 49-to-1.
That's exactly what I've done, and I'll even discuss that. I've been on hotels where I'm on the 7th floor, and my counterpoise is dropping out the window, and I've got a vertical radiator poking up and making lots of contacts. On one weekend, I worked 100 countries just making contacts that way. But it was
Wow.
during a contest all a bit. Okay, so some of these indoor antennas, if you do it yourself, I really, I experimented with mag loops before they were commercial mag loops. You can get yourself a big piece of hard line, piece of aluminum tubing, copper tubing, and you can operate 100 watts if you have a high voltage capacitor. You can make it for about $50. I've done that. I was amazed that it worked pretty close to within 1 to 3 dB of a full-size reference dipole, and got me on the air in a very confined situation. You do have to recognize you're going to get some real high voltage, so you don't want any kids playing around near the end of the loop or pets because they can get zapped. You're talking about, 1,000 to 3,000 volts coming at the end of that. But if you're operating even lower power, you're still dealing with significant voltage. I have one that fits in my suitcase. It's just an RG214, and I operate 20 watts with it with a smaller space capacitor, variable capacitor. And that's probably within about 2 to 4 dB of a reference dipole. Gets me on the air. You're not talking about, making DX contacts or breaking any pileups. But I've done both the direct gamma match as well as the mini loop. How you have the loop that makes the transformer feed to the big, from the small loop to the big loop. And but I get tired of it because you're always tuning everywhere you go. So I got a little spoiled. If I can set something up in the attic, it's all pre-tuned, never have to retune it. It takes all that game out of tuning. But in desperation, sometimes I was using my little loop in the suitcase. what I found real effective, and this is what that gentleman was talking about, using the window or balcony. If I can, I'll usually request, I'd like to be on the second, third, fourth, fifth floor, whatever. I will drop the counterpoise wire out, have my 9-foot vertical with a low loss coil. I do deal with a coil because I'm trying to keep it as stealth as possible off the balcony. And I have a telescoping whip coming off it, and I can get within about 1 to 3 dB depending on what band I'm using from a full-size vertical, and especially if I'm using really low-loss aluminum and copper coil. Typically, I'm even going for like 10-gauge aluminum kind of thing. So it's lightweight, fits in my suitcase. I was even going to bring it, but I didn't toss it in my car. And I'm set up for multiple bands, so you have to have multiple counterpoises, be ready for that, and highly efficient, especially when you get it elevated. Okay, other indoor antennas that might be do-it-yourself. I've even taped to the ceiling the full perimeter and set up a horizontal loop, especially if you're at the second floor or above. And you can really get pretty efficient horizontal loop at that location. Got a question?
Yeah, you said your counterpoise, you use a different length for different bands.
Yes. Yes.
Uh,
I have a length for each band I'm planning to operate on. A quarter wavelength, yes.
Could you use a trap in that?
I don't like it because I don't like losses of traps.
Very good.
You're typically dealing with 1 to 2 dB of loss.
Okay, thank you.
And you're talking to somebody who had a gigantic Mosley Pro 67 beam, 120 pounds, and I dumped it because of all the traps and went to an OptiBeam. Okay. But if you have enough room, if you don't have the room on 20 meters, you can, at the low current portion of the loop, you can do sort of like a bow tie kind of thing. And so you're linearly loading the loop again. And that will keep the losses to minimal, and you can fit your 20 meter in even a 12 by 12 room. You don't have to have like 16, 17 feet by 16 to 17 feet. So I've, in desperation, I've done that too to get it all to tune up. And you'll actually come closer to a 50 ohm match when you linearly load it like that. I've done it for 17, 15, 10 meters. And some people say, oh, I'll set it up one band and use an ATU. Well, you'll get a little loss. Maybe you'll get 1 to 3 dB of loss in that arrangement. So, again, stealth, operating 100 watts, I don't want any loss as much. I want to avoid as much as I can. Typically, the wife's not going to like it if it's bright pink wire, so I use white wire so it doesn't show up so much. And if you want to go the commercial route, you can go with something like an Ultimax 100. I've tried that out, but you're going to get some loss because it's a non-resonant end fed. In non-resonant end feds, you'll typically lose about 1 S unit, sometimes 2 S units. Now let's talk about what an S unit is, because I hear a whole lot of different definitions. What do you think an S unit is? How many dB is an S unit? It's supposed to be 6, but if you look at ARRL lab tests, almost all the popular transceivers are closer to 3 to 4 dB. Okay. Now, some people take, real pride in saying, I will calibrate it to 6, but not many manufacturers are doing it. So I found in my ICOM 7300 and many of my transceivers that it's 3 dB per S unit. So when you're talking about 1 or 2 dB, 1 or 2 S units, you're talking about typically 3 to 6 dB less signal on your non-resonant 24-foot Ultimax that you can string inside your place or put in the attic as well. And if you can get it up reasonably high, you'll still be working DX. At the end, you might be 1 or 2 S units down. And I've seen people walk it all through their house to finally make it work and tape it up and gets the job done still. Now this one looks a little different, the cobweb. Has anybody ever used a cobweb antenna? I talk to a guy in New Zealand regularly who's putting out a pile-up signal, but he's running 1,200 watts into his cobweb antenna at about 15, 16 feet high, and it gets out real well. Now he's got it in the clear, not up in the ceiling on the room, so he's probably, getting a good S unit being in the clear compared to you putting it up on the ceiling. But cobwebs are quite efficient, and they don't need to be rotated because they have a fairly omni pattern. They're this folded dipoles. You're going to reduce the impedance of your dipole from 70 ohms to around 11 or 12 ohms. So now you have to use a 1 to 4 balun to get it back to a 50 ohm impedance. But they're typically only about 2 dB less than a reference dipole. And I'm hearing a lot of people in HOA sticking cobwebs up because it's easy to hide. It's only 8 by 8 feet, so it can go up on a ceiling, it can go up in an attic, it can go up outside. Some people think, oh, it looks like one of those clothesline dryers. In fact, I even got a picture of one. There's a cobweb antenna right there. You can't see some of the wires on this picture, but you can see a portion of the wires. But that's basically about 8 by 8 feet, and it covers 20, 17, 15, 12, and 10. And you're talking about, you're not really losing any of your RF. It's all being radiated. It's quite efficient. It's probably 95% efficient. It's just that it's being more omni versus a broadside dipole. So it will be down slightly from a dipole, but you don't have to rotate it. So it's got a lot of virtues. Okay, now we're stepping into the attic. And I've been crawling through attics for 40 years, over 40 years trying these things out. If you want to see the attic Grand Master, there's a guy who was in QST who put wire Yagis all through his attic, but he's talking about a big attic. And he had whole switching arrangements to change the parasitic elements and turn his beam in the attic by changing wires in the attic and all that. And then eventually, I think he convinced his wife to buy several acres and set up an antenna farm instead of his attic antenna farm. But I got a kick out of it. But I've tried the dipoles in the attic. I've tried inverted Vs. I've tried full wave horizontal loops. I've tried mag loops. I get tired of that because you got to do a remote tuning arrangement, or either that you're running up into the attic, which is goofy. And then I've used a 40-meter end fed in the attic. You can zigzag it. So it's linear loaded. And then I've used a ZR-like vertical. Anybody ever seen a ZR vertical? ZR-like vertical? That's Mr. Tom Schiller's invention from Force 12. I'll show you a picture of it. And you can stick a cobweb like I showed you on that earlier picture. If it's 8 by 8, you can usually squeeze it up there. You're going to have to assemble it up in the attic. You aren't going to put it through the attic hole, the access hole. So, but here's what a ZR-like vertical looks like. So do you think that's linear loaded? It is. It's got a full length element for 20, 15, and 10. So all it is doing that little rotation. It's full length. Pretty clever. And I saw the field testing, and it came within 1 or 2 dB on pretty much all bands from a full reference vertical dipole. Not too shabby. So all that energy is going out. It's just that the angle of radiation won't be quite as low, but look where the major current area is. The center, that's not being rotated. The center is nice and clean, so you're getting a very good antenna out of that. And you don't need to make them out of metal if you put them in the attic. It can be on a PVC frame. It does take a lot of experimentation to get all of those resonant, and there sometimes you get a little interaction, but extremely efficient antenna. Now, I did mention, the full wavelength loop. That's been out of all these and trying all these in the attic. The full wavelength horizontal loop has been my favorite, and the reason why it's my favorite is it's got a lower noise level than dipoles and vertical antennas. And typically it's sometimes 1 to 2 S units lower in noise level. And when you're listening to DX, you need every bit of that lower noise level. And when it's sitting right above all your electronic devices, you need that lower noise level. So I tend to have migrated to a full wavelength horizontal loop. But if you're in a 1-story condo, that's pretty low height. You're going to be put most of your energy straight up as opposed to getting it at a good DX angle. So you typically want to get a good 20 feet to make it worthwhile. If you don't have 20 feet, I'd go with a vertical a vertical loop, and I'll talk a little more about that. So if you happen to be blessed with a tall attic, I've got one home that's got an 11-foot attic. You can use a one wavelength loop, vertical loop. And so you're still doing a whole one wavelength, but you're using the height of that attic and you're feeding it 1/4 wavelength from the apex peak, and you'll get about 50 ohms impedance. And that turned out to be, that was an award-winning antenna in both QST and for 80 meter and 160 meter DXers, because you can get very low angle radiation, very good efficiency, and the thing, you know, works real well. I've talked to a lot of people with them, and you're talking about, you know, you're very close to a dipole that's being mounted up fairly high with the low angle radiation. So it's about close to a 30 to 40-foot dipole. It's also pretty omni. It's been modeled and it's demonstrated to be pretty omni in directionability. If you have also a tall attic, I've seen people use inverted V dipoles. I tried it out. Was not a real fan of it, but that's because I was picking up noise. And that brings you into the discussion, attic concerns. Again, I mentioned no radiant barrier insulation or steel roofing is a problem too. Not too many people have steel roofing, but you see it a little more in snow country areas, steel roofing. Snow slides off a little more easily, but not so great for ham radio antennas up in the attic. I don't worry about the ducts or if it's composition, tar and gravel, tile. I mean, all of that, very minor effect on the radiation. You know, I would estimate only 1 to 3 dB, depending on just how much stuff is on top of that roof. But what I do worry about is power line coupling. I couldn't believe it when I was a teenager. My sister was telling me, "You realize the bathroom lights are glowing when you're talking?" And I said, "Okay, I got a problem." I was running 1,000 watts at least, and those light bulbs were just going right with my voice, because, you know, when you radiate that much, and that's even with a Yagi on top of the roof at 45 feet, it was doing that. But you know, your power lines can act like a good antenna. They might be nearly resonant for your frequency, picking up a lot of energy, bringing it to the light bulb, and away you go. You're lighting the light bulb. So you have to be aware of that. And so I've usually, I buy a whole bag of couplers, and I'm ferrite cores, and I'm snapping them on all different places that I have concern for interference, and I'm suppressing as much as I can. And I'll even mention this: I had some homes built, and I have the builder let me in and snap all my cores in before they close the walls up. You know, you can take advantage of that if you're having a home built. But if I really am diligent about that and suppress it, and you have to suppress it on laptops, phones, all those switching power supplies are just noise generators, RF noise generators. I can get my noise level down to S2 to 5 when it might be S9, S9 plus 10, if your attic antenna is right over all these noise generators. So you have to spend some time with that. And you have to evaluate all the appliances. I have a heat pump in a recent house I bought last year. The heat pump was S9 plus 5. I could hear the fan even roar, you know, as it's spinning around and all that. And so I had to spend time filtering both the compressor and the air handler. And I got it where I couldn't even hear it anymore. It was noiseless to me. And not all phone chargers are alike. You know what the quietest phone charger on the market is? Apple. I saw the lab tests. And I don't have an Apple, but I buy Apple USB adapters because they're the quietest. And so they did a lab test on them, and they were like 10, 15 dB below my Samsung, which was noisy as heck. So even though I don't have Apple stuff, I will buy their stuff because they engineered some suppression of the RF. And laptop supplies are some of the noisiest. I'm usually putting cores on that. And even your fluorescent lights are quite noisy, whether they're in the garage or kitchen, bathroom, you know, I'm suppressing that. And then I couldn't believe it. My family was telling me, "Do you realize when you talk, Dad, that your the security monitor lights in the backyard are turning on and off. That was a lot of effort. I had to suppress it, and I had to put a real suppression oriented AC line filter that was like 50 dB to knock that out. It was quite sensitive. I couldn't believe it. Yeah.
Aside from fluorescence, LED lights, if they don't have the filter capacitor on them, they generate noise like you wouldn't believe. I actually had that problem and it was really loud on 80 meters and 40 meters. I swapped those out and made that noise go away. But the ones without those capacitors in the light itself, if you if a lot of them come from China, it's just a shortcut they take.
Yeah.
I
agree.
so yeah.
So
just-
what I've done on some of them and still used them is I've done a few loops through a bigger core and also put a capacitive filter. So I'm knocking it back maybe 30, 40 dB. And I've had good luck doing that and still keeping with the LEDs. But you're right, not all LEDs are created equal, and some are much noisier than others. And they don't really have guidelines on it that really force manufacturers to put enough suppression on it. Yeah.
Thank you. Thank you. Yeah, I want to second the LED light problem. I had a just absolutely terrible problem with noise blowing out 15 meters and 10 meters consistently. And long story short, turned out to be the neighbor's daughter had had a string of those cheap Chinese LED fairy lights.
Yep.
And made friends with the dad and showed him the picture on the waterfall on my IC 705, and he's like, "Oh, I bet I know what that is." He goes inside and he unplugs the LEDs, and bam,
On.
F0
Yep.
noise.
Yep.
Yeah.
Yep. So if you, oh, Joe, go ahead.
Yeah, there's a device that you can buy for your house that costs about $50.
Mhm.
It's called a whole house power converter. And what it does is it acts like a filter for every device on your house. And nothing comes to you. You don't get no line noise from your neighbors. You can't hear none of that noise from the cheap solar panel stuff. It quiets it all. It's a whole house power converter. It's like what you use when you set up a media center,
Yeah.
power everything, or if you're like doing a rock band and you want to keep all the outside noise. And MSI computers, laptops got big ferrites on both ends of the power supply.
So all the magic can't happen from one big filter, because those lines, those AC lines act as nice antennas, and you got to suppress it as close to the source as possible. Yes. So that's what my experimentation is really proved to me. Now, some people say, I don't want to get in there and suppress all that. Well, there's one sort of cheap and dirty method. If you put a second antenna and you phase the noise out, you're tuning, trying to get all that to eliminate. And to me, I'd rather get rid of the noise and not have to be using these noise eliminators. Yeah.
When you're trying to suppress RF noise from some household device, like something with a switching power supply, where is the most effective place to place your choke, be it the snap-on ferrites or toroids or whatever?
I'm typically doing it as close as possible to the power adapter with my cores, and yes, it's right on the AC line going into it, and I usually loop it. So I'm talking about getting some sort of good sized ferrite cores to loop it. Yes, yes. So that's where you're going to get the most benefit. And believe me, I had to be house detective for anybody plugging anything in at the house. uh, but so when I did these performance comparisons, I made a comparison between my attic loop, which is 23 feet high with sloping ground towards Europe and many good DX locations. I used 12 to 14 gauge silver plated wired. I wanted to absolutely minimize the loss. And still, I'll be honest, it was still about 3 or 4 S units down from the OptiBeam at 74 feet. That's, my good reference antenna, but, no stealth antenna is going to equal that. So, but I was happy to do it because I still had about 60 countries worked on 2017, 15, and sometimes 10 over a 3-year period when I'm using it, 20 to 25% of the time. Now, these are signal reports that I would get with Europe with 100 watts. Now, I don't get 5.9 at the beginning of the band opening. It's more during peak band opening, and somebody on the other side has a Yagi too. And I can get 5.9 reports, which, that's sort of neat with your stealth antenna in the attic. And if they didn't have Yagis, I might get 5.5 report. I was happy with that, working, all the continents with decent signal reports with my attic antenna. By the way, you do have to use a 2-to-1 balun. I make mine super low loss, 10 gauge silver plated wire, Teflon insulated, multi-core, because I want every power going into that, every watt going into that antenna as much as possible. So my loss was probably 0.2 dB on that 2-to-1 balun. If you're limited to the first floor, I've done this many times, both in condos and temporary housing situations. I've used a vertical, the stealth vertical, which is typically a fishing pole blank rod because they're really low profile, very lightweight. And I've used a ring counterpoise. And I was amazed. Tom Schiller did some drone testing on that. Came out to be 95% efficient compared to a multi-wire counterpoise. When I saw that, I said, why am I wasting my time tripping over counterpoises when I can do a ring counterpoise? Really impressed by that. So I've been using that and found it to be very effective. And again, I don't recommend mounting it directly on the ground. Yeah.
How big does that ring need to be?
It's only about 2 feet radial arms, and you'll see a picture. I think I might even have it next on that. And then again, you can take advantage of trees. I've gone 20 to 100 feet. You're going to need something to launch it if you're getting up that high. But at 20 feet, I've used slingshots up to about 40 feet and done elevated antennas and you really get out a good signal. I was amazed at a 40-meter end fed, which I'll show some of that too. Go ahead.
Antenna and put the square loop around the bottom of it.
Yes.
For ground plate.
I picked up and I plagiarized his. The first ham show I said, and I started to challenge him. He says, I've drone tested this, 95% efficient. I said, okay, Tom, I believe you. And there's my version sitting at the campground. Now, do you notice anything near that campground? Yeah, the water. I picked up an easy S unit. I was talking to Europe all the time. I was talking to everywhere with decent signal reports, 100 watts. And those little PVC rods are just 2 feet, and they fully support a 20-meter counterpoise. And I'm using RG6 leftover junk coax because it's an excellent conductor. And I used RG6 quite halfway up the vertical, and then I used silver-plated wire. And so I was getting a very low-loss vertical antenna. And it's only about 4 feet above the water, so it's elevated, very low loss, and putting out a great signal. So the water, in all my DX directions was about 1 mile long, and it was great propagation. If you take advantage of everything, you can, here's a quarter wave vertical, doing great. Now, that's not your typical camping. I have to admit, I've moved into more glamping than camping. So it was a cabin on the water. Okay. Here's the outdoor stealth that I've say thumbs down now to, because I've done it. I've been through it, and it's just a pain. Center fed dipoles, inverted Vs, G5 RVs. you got all that feed line hanging down. It's no longer stealth. Your neighbors are going to be complaining. And on top of that, you got to carry the weight of that feed line and hoist it up. Whereas end feds, feed line is you've got it secretly sort of hidden onto a balcony and eave, all different, secret locations. You can make them a lot more covert. The wire you're dealing with is like 20 gauge. I use 20 gauge silver plated Teflon insulated wire. That stuff is so light. I can support it with a very limited kind of support pole. And so the feed line isn't visual, and the antenna wire is light, and then multi-banding inverted V's and dipoles and G5 RVs is a lot more work than a 49-to-1 end fed by a 49-to-1 transformer. I'm not a believer in flagpole verticals. They were, more popular 10 to 20 years ago. They're a real pain because you got to put a ton of radials down. And what do you think your neighbor's going to think? You're putting 100 ground radials down in the lawn. That's an invitation for trouble. Yeah. Yeah. Yep. Yeah. No, I've known some people who put in mesh and all sorts of things before they put the lawn in, if you're lucky enough to do that. Otherwise, you're carving up your lawn, but you're still warming the ground, and that's why I'm still not fond of it. The radiation efficiency is much lower than having elevated ring kind of counterpoise. And I've learned it from experience, so I've moved away from anything like a flagpole or ground mounted vertical. But instead, I really like 49-to-1 end-fed transformer arrangements. Anybody using an HF end-fed in this room? Okay. Okay. Well, I'm quite fond of them for a stealth antenna. I've got it at my Florida home, and I must talk to easily 100 countries on 40, 20, 15. I mean, it just really does a wonderful job. But you do have to figure out where the lobes are and orient the wires for where you want to aim your lobes of radiation, especially on 20 and 15 meters. And that's where Tom says, I don't like the end-fed because it's not an omni antenna. Because when you get into 2015, you're at multiple harmonics and you start having these 4 lobes for 20, 4 lobes for 15. But if those lobes hit where your DX locations are, you're blessed then.
Yeah, I was recently to an antenna talk and they were talking about the infed antenna. I said, how come all of a sudden there's such a so much talk about an infed antenna? He says, well, soda is increased my sales of infed antennas, I believe, more than anything. He's the company that makes the bullet, and I can't remember the name of the company.
Well, My Antennas is the largest manufacturer of end-feds, but I think HOAs are a big reason why end-fed antennas are so popular. I talked to so many hams. I'm in an HOA. I'm in an HOA. So if you want to go stealth, go for an end-fed. I've got it right in a Florida community. There's 500 homes there. It's an HOA. They aren't nasty about it, but it's invisible to the HOA. And I've got a 40-foot tree it's hung up in at the apex, and this gets out like gangbusters. Now, Florida, it does help because you have very conductive soil, and I'm about a mile from the salt water. So that is helping me, I'm sure. But I was just amazed at it. And I've got 8 dBi going into on 20 and 15 into Europe, into Asia, into Australia, New Zealand, into South America. I oriented the wire to put my lobes where I want them. So it's been very effective. And so there's the 66 footer I'm talking about. I tune it for 7.06, so your harmonics don't even have to have an ATU, low SWR, 40, 20, 15, and 10. And if you do 132 feet, quality suppliers, My Antenna, people are using them all of those bands without a tuner. That's quite a virtue. If you want to go outdoor DIY and you're stuck on the first floor, a ZR like vertical, you can hide them in 5-6 feet in space, in height, and you'll still be within a couple of dB of a reference dipole. And then I showed you that picture of a fiberglass rod with the ring counterpoise. If you want to go, yeah. Yeah, I have. It's silver plated wire though. Yeah. He was wondering if I used a 26 gauge wire for an antenna for, and I've operated 100 watts on it, silver plated 26 gauge. You'd probably want to get to, if it's copper wire, probably 24 gauge. And if you exceed 100 watts, which I did, I ran 150 watts and I put a carrier on and I could see the wire glow in spots. So you don't want to go continuous duty and you don't want to go beyond that, is my concern.
Yeah.
Go ahead. Oh, sorry.
Yeah, so one of my friends does a really fun trick with that. So he's in an HOA and he's running 26 gauge wire with an 80-meter end fed that's intentionally cut a little bit too long. So it's resonant on about 3.3 megahertz, give or take. And it's still below 2-to-1 on all the bands.
Yeah.
But then he can actually use an ATU to make it work on 160, just barely.
I see. Yeah. You'll get a more 160 meter efficiency on that arrangement. Yeah. No, I can understand. That's an option.
Yeah, back in 1975, QST came out with a quad band vertical that was then fed.
Mhm.
So I figured, okay, how do I make that? And what I did was I built a trellis out of 2-inch wood, 40 feet high, because this garden apartments I lived in would let us put trellises in, but they said no more antennas. They let a guy put up a TV antenna and he put a tower in and put a quad up on it for 11 meters. So anyway, I built this 40-foot tall trellis, made it 4 bands instead of 3, and planted trumpeter vines on it. And I put aluminum tape, and then I doubled up the 2-inch things on the center. And then I have 5 of them on the sides, 3 on each side or 2 on each. Yeah, 5 total, but only the center was thing, and no radials or nothing.
Yeah.
And, with 100-watt Kenwood 140S, I worked the world.
And a lot of people are using vertical end feds. Now it's not easy getting 66-foot vertical, but when you have a tree, that's a possibility. And you'll get very low angle radiation from a 66-foot vertical. Yeah. Go ahead.
You said that coils lose too much, by heat, lose too much energy. Has anybody tried to make a coil using copper tape like Keith over here, K1OKS,
Yeah.
or his,
Yeah.
or aluminum tape?
Yes.
Could you make a coil with 1-inch tape on some frame?
Yes, you
maybe
could.
Paper?
And
That'd be
you
better?
would reduce the loss considerably because it would be, yes, much better conductivity. I've even used copper tubing, pretty heavy duty, like 1/2-inch copper tubing and an air core coil. Yes, you will reduce it. And if you've ever looked at those big, huge 40-meter and 80-meter beams that are loaded, that's what they're doing, typically using very large coils to reduce the loss. So, but again, it's a whole lot easier for me just to go linear loaded and use the wire itself, and you're in about the same game as a very low loss coil. Let's see. You can go really low loss magnetic loops, especially if you want to go commercial, but you can make your own. I've used it. The hard line that they use for cable TV. I think I used 1-inch hard line, and it was very low loss. I was probably getting within 1 dB of a reference dipole with a magnetic loop. So the conductivity is incredible on that. But that's not something you put in your suitcase either, though. But you can use LMR 600, which is pretty low loss, and that you can fit in your suitcase. Now, what one ham is doing, he's using an intermediate size loop. That's more than a 1/4 wavelength loop. And it's called, I think it's KM6T. And he's had very good effectiveness on 20 through 10 meters in his HOA on his balcony using an intermediate size loop. You'll get much lower loss. You'll probably get within 1 dB of a reference dipole. The capacitor will be much smaller in capacitance, but you'll still have a lot of voltage. So he's using vacuum variables, very high voltage vacuum variables, and getting excellent bandwidth. He doesn't have to tune. He's getting typically a couple hundred kilohertz bandwidth. So that was pretty neat. Anybody ever try a rain gutter in Teta?
Not yet.
In desperation, as soon as I get into a home, sometimes I use the rain gutter. And I went even more than that. You typically using a 4-to-1 or 9-to-1 balun. You're picking up some noise. It's got all sorts of issues, but it gets you out there. But what I thought is, hey, I've got a big, huge aluminum soffit that's going around about, a couple 100 feet on a large home. And I've got a aluminum patio room as my counterpoise. I put my antenna analyzer on it. It tuned from 160 through 10 meters with less than 2.5 to 1 SWR. I was blown away.
Whoa.
Yeah. But the trouble is, it was all like 80, 90 degree radiation. So I couldn't work any DX for beans. So it was a little bit frustrating. Yeah.
Nah, work in the clouds.
What's that?
So you were mentioning rain gutter antennas. There was a
Mhm.
echo coming here. Huh? Oh, okay. So I was playing around with rain gutters at my friend's place in San Francisco City, in the middle of the city. We noticed that there were two downspouts that were exactly the right size to make a 2-element 40-meter Yagi,
Oh, wow.
pointed exactly at Europe. So if you lengthen one of the elements, the one that is farther away from his house, by adding an alligator clip and a few feet of wire, it becomes between a director and a reflector. So you can hit the long path or the short path. So
Yes.
this is like a software-defined antenna. You use NEC to build
Yeah.
the antenna.
Well, you have to have some luck, but like I mentioned, you want to survey what's in your environment to see how you can take advantage of it. And that would be an excellent way to take advantage. I got so frustrated with my soffit and aluminum patio room antenna that I went to the 40-meter end-fed and I compared the two side by side with many DX Contacts 3S units. So I said, that's a loser. But it helped me in a bind when I wanted to get on the air quickly. Yeah. So you can go commercial magnetic loops. Have you seen the price tag on the big boy ones? Whoa. Hamfest and from the Russians. I've got a few of them, but you have to be at those Hamfests when they come up sometimes. But that's what they have is vacuum variables, and you're talking about $2,000 to $3,000 magnetic loops. They aren't light. They don't put in your suitcase. Some of them are 25 to 50 pounds, like the big one, that Ciro Mazzoni or something like that, the Italian one. And even the QRO Precision one is a pretty hefty guy, but that's, I think, LMR 600. That's $3,000. But people I've talked to, I've heard people working DX Contacts, and they stick them in their back patio, and they're semi-stealth. Sometimes they raise and lower them on a tripod kind of arrangement. Yeah.
Fest here. I was at Hamfest here recently and saw one of those Italian loops laying on the ground. I said, they're supposed to be pretty good. And he said, they are, but the neighbors don't like them.
So you might have to raise and lower because they don't look that stealth. They are, but you could say, wow, the 3-footer, that's sort of my satellite dish. But out of the end feds, if you want a commercial one, my antennas, I think, is the superior product. Not all end feds are created equal. For instance, the MFJ is an auto transformer one. You have to really work your ground situation more carefully with an auto transformer versus a conventional transformer. My antennas are conventional transformers, which allows you to elevate the mount and not have ground issues. Yeah.
One thing for you on those magnetic loops, you don't want to have them very high elevation. They're actually supposed to be close to the ground.
I'll caution you about that. If you have them vertical, you don't want them that high necessarily. If you have them horizontal, you want them high, because then they have horizontal polarization and they don't work with beams, but they are omni when they're horizontal, but they are semi bidirectional when they're vertical. They get a null. They have a big fat pattern, but with a null. So I've played with them both ways, and yes, you will pick up, if they're horizontally mounted, an omni pattern out of them, and you want them elevated like 30 feet or so. Yeah. Okay. Dual. I ran into this one guy. He was pretty clever. He had two end feds rather than trying to absolutely orient all the lobes. He had two to choose from, and he just switched between the two, and he was working like gangbusters. Whichever one he would choose. Okay, here's some of your alternatives if you run out of solutions. I've talked to some people who have their mobile antenna on their car, their big screwdriver antenna, the Scorpion screwdriver. I think those are around about $1,000 or so. And he runs his coax extension into his condo. and he says, "Hey, you can't shut me down, HOA, because it's on my car." And then there's the remote station, where it's not in the HOA environment. Their station, I've talked to a lot of them in Europe. Their stations in the countryside location, and they're operating remote downtown using their remote station and doing quite well with a 3-element quad at their countryside location. And then there's the rental homes on a large county lot when they're living in an HOA home development. And there's HOA homes right on the saltwater with the boat dock. I've talked to people in multi-band verticals that are getting out like gangbusters. So all of those are possibilities, but you also have to sort of pick your home based on that. Here's the home I'm working with right now in Florida. At the back of that property, there is 2/3 of acre of my property, county forest, and I'm planning to put 2 towers in my HOA home, but I have to run the coax out the backyard. So that's a way of working around the HOA. I just had that built about 3 months ago. Okay, here's the class exercise. We're winding down. Okay, the class exercise. Here's a Palo Alto townhome. I want to hear from you after you've heard all this information. What would you choose for your antenna if you lived in that Palo Alto townhome right there in that picture?
Call a realtor.
HF 40 through 10 meters.
Okay. Something in the attic.
Yeah. That attic is game for me.
Yeah, that's at least stories.
Mm-hmm. Okay. Somebody pointed out the tree. Oh, that's a good one. You see the trees in the backyard? You can go stealth with that tree.
Oh, yeah.
Yep. There's all, and you notice those big downspouts too. So here's some.
Oh, yeah.
Okay. The 3rd floor attic, you could put horizontal loops up there. They'd be 30 to 34 feet high. You get some excellent characteristics out of horizontal loops up there. You'd spend some time up in the attic, obviously, but it's a townhome and you should have attic access.
Yeah.
You could go with a mag loop, but you'd want it to be remote controlled. And there are some, but if you're talking about those Italian ones, you got to do a construction effort practically in the attic. But you didn't get the peek behind, but I actually peeked behind, and there's a real rear balcony at the 2nd and 3rd floor level. You could have a Scorpion screwdriver right on that balcony. You could do a 40-meter end fed. Somebody noticed the trees. It could go from the balcony up to the tree, shoot it down, and you'd have a nice inverted V off that tree in the back. You could go with fan dipoles. That's a little bit too non-stealth, is my opinion.
Yeah.
And yeah, that's true. But then you have to worry about the roofer tripping over it. Oh, under the, okay. I see. Yeah. And then you could do with the mag loop or the intermediate size loop on the balcony, like I was talking about earlier. And if you're desperate, you could do the rain gutter antenna, unless it really aligns with what you want to radiate parasitic level. Yeah.
I think about a year ago, someone gave a presentation at one of these meetings about a loop antenna where you just run a 20 gauge wire around the entire side of your attic.
Yes. And more or less, and then some people put ATUs on that all around the attic scenario. I tend to go for the resonant because I want a nice omni pattern, 20, 17, 15, 10, and I will tune each one for those bands and commonly feed it, and I get a nice, beautiful omni pattern, and it's resonant, and I'm putting out all my energy. Now, here's antenna comparisons. Now, if you this is sort of the nerdy view of it, but if I use my 74-foot high opti beam up on the big tower, and if my average signal was roughly about a 5.8, which is not, I can get 5.9 plus 10 when a 6-element Yagi's pointing me, and it's a big signal propagation, peak conditions. But on average, I might get a 5.8 signal. If I had a hex beam, I might get 5.6 to 7. If I'm dealing with an indoor mag loop, probably a 4x2 to 4x3. So this gives you an idea out of all those antennas that I was describing, what my assessment would be based on the DBI rating from modeling or my own experimentation from trying to use it, and what kind of signal reports I was getting. If you're lucky enough to get peak conditions and everything lines up and the gray line is just working great for you and all that, you might do better. But on average, this is what kind of results I would get. And if you look at the external antennas, you're getting a little bit better from 40 and 80 meter end feds, a 5/8 wavelength vertical, a lot of bang for the buck. If you want to take a macroeconomic view of this, you're paying about $1,000 to $2,000 an S unit to get on this path to get better and better signals, and it gets exponentially increasing when you're going up to the very exotic end, which is rotating towers with stacked beams and all that kind of stuff to pick up an S unit. I don't know if you've seen KE5EE's webpage. He has 6 stacked beams on a 200-foot tower, and he's rotating the whole tower. He's got one of the best signals out of the U.S., but that's quite an investment. That's not your average ham station on 5 acres. Yeah. So that gives you an idea of the antenna comparisons. I'll take any questions.
Hey, Mike, this is a wonderful professional quality survey. Have you considered writing an IEEE paper or a QEX? You can get $50 a page. It's wonderful.
Oh, thank you. No, I've grown past all my nerd history, and I'm just down to tinkering and playing with things. And I could give another briefing, which was a lot of fun. On my bicycle, I rode back and forth to work every day for 25 miles round trip for 25 years. And I went HF bicycle mobile for 2 or 3 years and had fun talking to 40, 50 countries. Well, I was riding my bicycle to and from work. But it was a 12.5-foot vertical. And it was a lot of fun, but a lot of people didn't believe I was on my bicycle.
I've seen a diagram of the end-fed, and they're using a choke on the feed line.
Yes.
As the other half of the counterpoise is such.
That's a good point you bring up. There's been a lot of studies that show most end feds, you pick up a little bit of common mode signal on the coax. Okay. And it's good. I typically put ferrite cores on it right where you feed it. And some people put a little bit of a counterpoise wire so it will go on that wire versus down your coax shield. If you use an auto transformer, which only about 2 manufacturers have, MFJ being one, you're more prone to that. I use the auto transformer because I got the highest efficiency. My end fed was only mounted at 10 feet. So I had 2 heavy duty braided lines going down to 2 big ground rods, and I had all the ferrite cores. So I didn't have any problem. And I was within 15 feet of my ham shack location operating.
Thank you.
Got one more over here.
Yeah, so with the various attic loops and ceiling loops that you talked about, there was a lot of focus on omnidirectional have you tried doing something like a phased array with either multiple loops or multiple linears to try to get some sort of directionality and gain?
I have not. I have not, and I've tried to just keep to the Omni and get as much signal out, and and actually, when I'm listening, many of the people with hex beams and other stuff are not too far off from hearing about a similar signal, but they definitely put out a bigger signal than me. They're about 2 or 3 S units more than me. So I could pick up more. I was impressed with a guy in Germany. I forget his call sign is a DL6. He did that. He did 3 magnetic loops in the attic, set them up as parasitic elements. But I found out what was more of his secret sauce. He had 1,000 square feet of copper counterpoise. And I was wondering, why is he as strong as people with hex beams? And when he took that, he could switch that in and out. It was like easily 2 S units. So the magic wasn't as much from his loops as it was his copper counterpoise.
Have you considered installing salt water in your attic?
Other than having a lot of attic leaks, no, I have not. But I've been tempted to buy a property on the coast of Florida because there's so much salt water. I don't want to necessarily live on the coast of Florida because that's hardest hit by the hurricanes. They're usually about 130 to 160 miles an hour when they hit the coast. By the time they get to my home, they're 70 to 90 miles an hour. So I'd rather not be right on the coast, but it'd be nice to have an antenna right on the coast.
How about a saltwater swimming pool?
Yeah, that could improve things. Yes, you're right. That could. The bigger the pool, the better.
Thank you very much, Mike.